Hello everybody, we have one-step equations with multiplication and division. So, we're solving equations. Solving equations can also involve multiplication and division, but the same rules apply. So we're always going to start with the side with the variable, and we need to use the opposite operation of what's being done. So let's take a look at this equation right here. So if we look at our key to the right, we can see that our x's are represented with our long rectangles, our positives are represented with the white ones here, and if we have a negative, it's going to be represented with gray. So if I'm reading this equation, I have 3x's, so I write 3x, and it equals 12. Now, we are going to practice solving this equation. Right here we have 3x. You know that a number next to a variable is multiplication. So what's the opposite of multiplication? It is division. So I'm going to use my algebra tiles as well to help solve this equation. So when I'm taking my algebra tiles, I want to flip them, essentially doing the opposite of multiplication. So I'm dividing on this side. Now, when they are flipped, I'm dividing it by 3. Now, on the other side, I have 12, and that also needs to be divided by 3. Essentially rearranging those algebra tiles so that it fits equally into each group. Now, again, these sides will cancel out, and 12 divided by 3 is 4. So when we're solving one-step equations, the variable must be alone or isolated. Remember, alone is the same as saying isolated on one side of the equation. To isolate the variable by using the inverse or opposite operations. The equation must remain balanced, and you can always check your work. Alright, so let's take a look at number 1, for example. My expression has 2 x's in it. So I have 2x, and it equals 6. So how do we solve this equation? Well, if multiplication is being done here, I have to do its opposite. And I'm going to use algebra tiles while I'm doing it. So I'm going to divide each side by 2. So I'm going to take my tiles and flip them. And I can rearrange them with equal groups in each tile. And what happens here is that my x's end up canceling out. My 2's will end up canceling out to leave x alone. So essentially I have nothing there. And 6 divided by 2 will equal 3. So I have 6 divided by 2 equals 3. Now, if you wanted to check your work, you could do that by substituting x, because remember, x equaled 3. So all I have to do is multiply 2 by 3, and I'm going to get 6. And if I got the same answer as the original, then I know my answer was right. Okay, so here's another example. On the left side of the equation here, I have 2 1s, so I have 2, and it's equal to 4 x's. Now remember, either way, my equation needs to be balanced. So I'm always going to be starting on the side with the variable. In this case, it's going to be the right side. So I want to get rid of that 4 to get x all by itself. So I need to divide by 4 to get rid of it. And I can divide by 4 on this side. Now what happens is that the x ends up being by itself. So most of the time we just cross out there, right? X comes down, and it's going to equal 2 divided by 4. Well, 2 divided by 4 is a little bit different. So if I have 2 divided by 4, I'm going to get 0.5. And I could say 0.5, but what is that as a fraction? Well, 0.5 is considered 1/2 if you remember your decimals and fractions. So I want to write 1/2. Now, in the video below, it's going to show you how to do this using algebra tiles. Now, the tricky part about the algebra tiles are when we have more x's than the amount of ones there. So here's a quick example on how to do that. Okay, so now I have 4 x's, and I'm dividing it by 4. Now the tricky part is that I only have 2 ones over here. So that means I have more x's in each group. So how many ones will fit? Well, basically what ends up happening is that when I go to group these, the 1 is going to be divided in half, as you can see there. Or another way to think about it is if I drag these x's, I'll be able to fit 2 of them into 1, making it a half. A little bit tricky, not my favorite thing to do when I have algebra tiles, to do it in that way. I think it's a little bit easier to just do it in this way, alright? Just as procedurally, alright? It makes it a little bit easier, but to visualize it, it's a good way to see tiles that way. On the top of your second page, you had 92, and then you had these t's, right? So how many t's were there? There were 8 t's, and it's going to be the same amount as 92. So I have 8t equals 92. So again, I want to start with the side with the variable always, and I need to get rid of the t. And since multiplication is being done, I need to undo it with division, because the opposite of multiplication is division. So I'm going to divide each side by 8. Now what happens to that is 8 divided by 8 is that it goes away, and all I'm left with is t. And 92 divided by 8, if you are doing it with a calculator, you would have the top number divided by the bottom number, and you're going to get 11.5. In this case, we are talking about money, so it's not 11.5, it ends up being $11.50. Now if I wanted to check my work, I could do that. I could take my variable, which was t, and say that it was 1150, right? That was what I got for x, and multiply it by 8, which was in my original equation. And if it equals 92, then I did my work right, because I'm substituting what I got for x into my original equation. So if I had 8 times 1150, and I know my work is right. On the top of your second page, you had 92, and then you had these t's, right? So how many t's were there? There were 8 t's, and it's going to be the same amount as 92. So I have 8t equals 92. So again, I want to start with the side with the variable always, and I need to get rid of the t. And since multiplication is being done, I need to undo it with division, because the opposite of multiplication is division. So I'm going to divide each side by 8. Now what happens to that is 8 divided by 8 is that it goes away, and all I'm left with is t. And 92 divided by 8, if you are doing it with a calculator, you would have the top number divided by the bottom number, and you're going to get 11.5. In this case, we are talking about money, so it's not 11.5, it ends up being $11.50. Now if I wanted to check my work, I could do that. I could take my variable, which was t, and say that it was 1150, right? That was what I got for x, and multiply it by 8, which was in my original equation. And if it equals 92, then I did my work right, because I'm substituting what I got for x into my original equation. So if I had 8 times 1150, and I know my work is right. So on number 5, I have 12 equaling x divided by 4. So if I want to solve that, it's x divided by 4. I need to use multiplication to get x by itself. Remember, I'm always starting on the side with the variable. I want to get x by itself. Since x is being divided by 4, I have to use our multiplication. And I'm going to take its reciprocal. So my denominator will go on the top. And the reciprocal right there is 4 over 1. And what I did to the one side, I have to do to the other side. So I'll have 4 over 1 here. Okay? These will cancel out. And all I'll be left with is x. Okay, so basically what I did there is I got rid of everything except for x. So now x is all by itself because I multiplied it by its reciprocal. Now all I have to do is 4 times 12. And I always like to make it clean by writing it as a fraction, right? But essentially it's just 4 times 12. So when I do that in my calculator, I'll have 4 times 12. And it's going to equal 48. So x equals 48. And again, if you wanted to check this, and whatever you got for x, my original equation was 12 equals x over 4. So I can substitute 48 in for whatever I got for x. So I had 48 for x. And it was being divided by 4. And that means on the other side I should get 12. So I had 48 divided by 4, and I got 12. So I have the right answer. So if you're going to be representing division like this with algebra tiles, my expression was x divided by 4 equals 12. Well, I'm going to have an x over here, and I'm going to be splitting that x up into 4 because x is being divided by 4. So now I have 1, 2, 3, 4 sections. Now each section is going to be worth 12. So I have my x being divided by 4, okay? And each section is going to be worth 12. So essentially I have 12 times 4. Or you could add these up. And as you got from your answer, you knew that was 48. And if I added them up, I would get 48, because remember, multiplication is also repeated addition. So each one, when I divided it, equaled the same amount on the other side. So it was 12, 12, 12, and 12. Each one of those sections has 12 in it. Okay, so on your packets, you guys need to complete 1, 3, 4, 6, and 7. But I will do a couple examples with you real quick, but you will need to write these in on your packets. So for number 1, we had 3x equals 12. So I have 3x equals 12. Now I need to start on the side with the variable. This is multiplication, so I need to use division to separate the 3 from the x. So I'm going to divide by 3, and what I do to one side, I have to do to the other side. My 3's will cancel out. X will be all by itself. And 12 divided by 3 is 4. So there you go. There's your answer to number 1. And if I wanted to check my work, I could plug in what I got for x. So I got 4 for x. X was equal to 4. So now I can have 4 as my x, and my original equation was 3 times x, and what if I perform that and I get the same answer on the other side of my equation? They are balanced. So I have the right answer. Alright, one of the last examples I'm going to do with you here today is number 7. Alright, we have x divided by 7 equals 4. So I want to start with the side with my variable on it. I can see division is what's being done. I have to do the opposite to get x all by itself. So I want to use its reciprocal. So I'm going to multiply what's there by its reciprocal. Now it's going to end up being all by itself, but don't forget, I have to do to the other side what I just did to this side. So I have to multiply by its reciprocal on that side. Now what ends up happening is that all this goes away, and all I'm left with is x, and then all I have to do is 4 times 7, which is 28. Because essentially, what I did here when I multiplied it by its reciprocal is I made everything go away that was on this side. So all I was left with was x. And then the other side, the other reciprocal, had 4 times 7, so all I had was 4 times 7, which is 28. Now again, if I wanted to check my work, I knew that x was equal to 28. So, since x was equal to 28, I can plug 28 in to my original equation. So I had 28 divided by 7. Now if that's equal to 4, I'm good. There you go. Alright guys, that's going to be it for today. Everybody have a great day and stay safe.